Okay, well, I'm going to do what you're not supposed to do in presentations and start off by apologizing for two things. Um, uh, my presentation is quite a bit different than Jared's and probably not as interesting. And I have some math. It's all symbols, no actual numbers, so that's good. I just finished putting together this presentation at like 10:15, so haven't practiced it. So those apologies and caveats out of the way. I'm going to talk about information potential and particularly trying to figure out what information is so that we can actually know what has information potential. So this is a summary of an idea that I've been working on for a while and is in press right now. And so a lot of this you're going to see, because I had to take the short way out, are screenshots from that article that is working its way through publication. But I've shared these ideas with the OAC before back in, here, let me go to my next slide, because that's actually what this is about. So a brief history of how I got to this point. James Glick's 2011 book, The Information, I listened to as an audiobook while riding my bike. And so since Jared had we didn't coordinate on this, but Jared had a picture of him doing the background for his presentation in his presentation. This is what I look like when I was doing the background for mine. I ride my bike to and from work, all weather, and occasionally my beard freezes to my face. So those are beard sickles. And so in 2012, 2013, I was reading this book and started to think about applying formal information theory to archaeology. Then in 2014, Kevin Swartz organized a roundtable to talk about how contract archaeology deals with lithic scatters. And so I presented some of those, the beginnings of this idea there. So some of you may recognize some of this. And then I presented it at a TEDx event here at Ball State. And so in 2015, so minus the beard sickles and most of the beard, actually. There's that's available on YouTube, and I don't know if you guys can see the views there, but it's apparently not very popular. It's only been viewed 190 times in 5 years, so maybe it's not worth talking about. I don't know, but you're stuck with me now. And then just this spring, my article that finally, after 7 years of working on it, is now out, available on Springer as the preprint version, and so there's that. Okay, so this is also framed in the terms of getting value out of public investment in archaeology. So we invest lots of money every year as state governments, federal governments on mandated archaeology through the Section 106 process. And so there has been lots of discussions about value. One of the better value in archaeology. One of the better ones that I refer to is Leip's 2009 article. Value in archaeology, there are actually two kinds of value. We can value something, what we value, what's important, but also something that has monetary value. And so we do want to get a return on investment for the public, and so that would be the monetary value. But we want to. This is where that apology comes in, because I didn't actually rehearse this. Well, I haven't rehearsed this in 5 years. There we go. And so we don't want to emphasize the monetary value of the archaeological record, although we do want to provide something of value, something that is important, beneficial, as a response to the public investment in archaeology. So I should have actually looked at my animations that were coming up, and that would have helped me stumble through that a little bit easier. And so as most of you, at least on the WebEx, know, and apparently Eric's students, there are 4 criteria for evaluation for the eligibility for the National Register of Historic Places, A, B, C, and D. And as most of you who are probably on the WebEx know, most archaeology ends up defaulting to criteria D, information potential, although archaeological properties and sites are eligible under the other criteria as well. And so, in fact, a lot of times in a lot of the literature on significance, people refer to criteria D as the archaeology criteria, and criteria C as the architecture criteria, which archaeology sites are eligible under C as well. And so what I would like to talk about is what is information? How do we figure out whether or not an archaeological site has the potential to yield information if we take another sample of that site? And how can we justify the use of public dollars to get that value out of the archaeological record? So I'll move on. So in summary, there's how eligibility is often conducted. I stole this. And then yes, my cursor, but I'll do this. So this paper here was a presentation that was in that 2014 roundtable, and it kind of summarizes a lot of the other discussions on eligibility discussions in CRM, and it's defaulting to that archaeology criterion, taking the easy way out, that if it's an interesting site, you say, oh, well, there's information potential, without justifying what information is. And one study has showed that about 12% of the reports that are available actually specify which criteria they're using when they say that it's eligible and requires further work. And we should know that we need to justify our recommendations for additional work in eligibility based in the criteria. And so there's a way to conceptualize this that I'm framing, that we have. I'll go back here to this. We can look at the criteria mostly in 2 different groups. We've got this top group here, which I'm conceptualizing as the humanistic significance, humanistic value, and then the criteria D as as the avenue for preserving scientific value in the archaeological record through CRM investigations. So if we split that up, then we can do 2 different things with our public archaeology, and do things that people value, hold as important, and we can do things that are important for science and get representative samples. There are patterns in practice about what kinds of sites are recommended. It tends to be the same kinds of things. I think it's Tainter who uses the National Geographic principle that if it's big, if it's got lots of fancy things, or if it's very obvious, then we go to that and we recommend those kinds of sites as significant, as eligible for the register, and we don't look at all the other parts of the archaeological record. And so this is, if CRM is the future of the past, if we're sampling the same kinds of things over and over again, when we get into the future and want to study the past, we will have an extremely biased sample of that past from which to learn from. And so here is a matrix that Evan Peacock developed for a paper he presented in 2012. tracking the distribution of the frequency of different kinds of sites that are recommended. And you can see that there's a cluster over here that is heavy artifact density, intact features, very old, and maybe a little bit of unknown function, where we don't get light, recent, unknown functions sampled. And so again, we're sampling this small portion of the possible distribution of archaeological sites over and over and over and over and over, and we're finding the same kinds of things, same kinds of villages, same kinds of campsites, and we're not exploring the vast majority of the archaeological record. How much of the archaeological record this area over here actually constitutes? Those estimates range from 70 to 95% of the actual sites that are out there are the ones that, for the most part, we ignore by rote, and we don't look at them, and we resample this 35 to 30% over here repeatedly. And so how can you do science with a small and biased sample of what you're trying to study? Well, the answer is I don't think you can. This is just a figure from the article, but it shows the distribution of significance discussions in the peer-reviewed literature, and I stole this from Breyer and Mathers, 1996. But you can see that there is a distribution. You can't really see the code on there very well, but there's some patterns. You have some things that are persistent. These are the different columns here are the different decades, and there are some things that are persistent discussions, some things that don't get very much discussion, and then some things that are kind of in the middle. Since I'm not sure what I planned on saying about that figure, you can read the article and find out what I said about it. More to the point, though, when we are making these significance recommendations, this is a distribution. There's two studies, the Peacock study that I mentioned earlier from 2012, and then a master's thesis by Hebler in 1996. And they tracked the type of recommendations that were made. And you can see that for criteria, where's the one that says no criteria? Well, very few of them end up, it's less than a quarter of them actually specify their recommendations in terms of the eligibility criteria. And so we end up with most of the recommendations are made that are not actually tied to those criteria. What most are using are the number of artifacts, the density of features, and the date, and those aren't criteria. Those aren't part of the criteria. Interestingly, we have positive and negative recommendations based on integrity, which is only a criteria consideration. That if you have something that would meet them, but it doesn't have integrity, then it goes away. So having a positive recommendation because of integrity doesn't necessarily make sense. And now this is just again, as promised, screenshot from the article. But there's also issues with the standard methods that are used. We know about the weaknesses in these methods, and we keep using them, and we're not adding new methods to them. And so this could be a very long discussion, but I just wanted to highlight one thing about continuing to think about the relationship between what we find and what it is we're actually looking for, what we're trying to talk about. And so I also wanted to call attention to this 2018 thesis by Dunlop, which I think is a very good discussion of the difference between the things we find with certain sampling methods and artifact scatters and the sites and the behavior patterns that we are trying to talk about. And so we often get lost going between the sample and the behavioral context without explicitly connecting those things. And this is not just limited to CRM either. but won't take the time to completely dig into that. But there are issues with the methods that we use to characterize the archaeological record that leave some things out or leave uncertainty in what we are looking for. And actually that uncertainty is the principle that I'm looking at. So what is information theory? So information theory comes out of World War II and the efforts to develop cryptographic systems and keep things secret, but then also to try to get things that are supposed to be secret or hidden or partially understood and fully understand them. And so the parts of information theory that are the concepts in information theory that are important are there is a source, which is something that is generating a signal, whether it's supposed to go to you or to someone else, but it has its own structure, its own statistical structure and patterns within that. And so there is, with that structure can be complex or it can be simple. It can have some redundancy. All signals and all sources are going to have some level of redundancy, and it is part of the error checking code in terms of communication, ensuring that your message gets through and is understood. If you send it without any redundancy in the message, then you're going to lose the message. And estimates of written English put the redundancy in the message anywhere from 50 to 75%, depending on how big of a reference frame you're considering. So in fact, most of the words that I'm using right now, you actually don't need to understand me, assuming you can understand what I'm saying anyway. And so the source will generate a signal, and that signal is transmitted over a channel. And so those things may not seem obvious in how you can translate that into the archaeological record. But I think we would all acknowledge that there is a structure to the archaeological record, that there are patterns and things that are associated with each other. And then if two things come and they're associated with each other, then we can recognize that there's something that's coming next that we could go and look for. And we could put an approximate probability on whether or not we would find that. And so there is a structure to that. And so the past human behavior can be treated as a source, and the materials in the archaeological matrix can be treated as a signal, and the archaeological matrix can be treated as a channel. It can also be treated as a source of its own, a secondary source that we can sample repeatedly to try to understand that structure and quantify that structure, to figure out what we know about it and what we don't know about it. Which brings me to what is information? Well, according to Claude Shannon, the father of information theory, wasn't the first person to actually make this connection, but he defines information as entropy, which is quantitatively similar to thermodynamic entropy. It's not completely clear whether or not they're the same concept, but it is the uncertainty of the uncertainty that remains in a setting given what you know. And so it's if you know everything that is going to be transmitted on a signal before it's transmitted, then the entropy is zero, and anything that you get from that source has no information and you don't really need it. And so in order for there to be something that is useful, you have to have some level of uncertainty in order for that transmission to actually be meaningful. And so this is H is formula for entropy and for quantifying information in the quantity of information in a signal. And so you take the log of the probability of an individual signal times the probability of that individual symbol, and you sum it for all of the probabilities, and then that gets you your entropy. sounds very complicated, and I was intimidated by it initially. That's why it took me 7 years to actually write this paper, but it's really not that hard. So here's an example from English, and I'm going to have to look at my article here to, well, assuming I still have PowerPoint up. There it is. Okay. So this is why I apologize first. So if you're given a sequence of letters starting off T, H, and then a blank, what's the next letter going to be? Is it going to be a Q? Probably not. For me, my estimate of the probabilities is that you're more likely to have an E, an A, an I, an R, a O, and a U. Well, that's not quite right. The actual order, at least according to a word list at Word Tips, is EIRAUOYW. But I was pretty close, and we both expect that the next letter is probably going to be an E. So that next letter, that third letter, doesn't have a high level of entropy. There is a good amount of predictability there. But there are still some unknowns. And to go to the other extreme, if you take the letter Q, you get Q in a normal, starting off the beginning of a normal English word, what's the most likely sequence of letters to follow? Well, it's probably going to be a U. If you had to pay any amount of money whatsoever to figure out what that next letter was going to be in that word that you see starts with a Q, I'd be willing to bet most of you are not going to pay for that next letter. You would skip ahead. And that is because that next letter has a very, very low level of entropy. It carries very, very little information. And so even though we have a relatively predictable sequence with the TH starting, that Q it's a much, much higher level of entropy for the TH word than it is for the Q word. And now this is very simplified. It's only character by character and not talking about meaning. But that hopefully illustrates what I'm trying to get at with whether or not you're going to take an archaeological sample. Can you predict that next observation? If you have a Q in the archaeological record, you don't necessarily want to pay a lot of money to get that U because you know it's already there. There may be another reason to get the U, but it's not because it has information. Okay, so how does this work applying to the archaeological record? I'm arguing that criteria D and information potential should be defined in terms of formal information, in terms of conditional entropy. That is, the entropy based on what you already know. And so when you start out, before you go out into the field, before you get that magnetometer out, before you get your shovel out, you have a certain amount that you already know. And so that's your starting point of your entropy. And as you take more samples, your conditional entropy reduces. And there's always going to be a remnant level of entropy. And that is, hopefully, you're going to eventually reduce your conditional entropy to the level of uncertainty that is in the original source that you're trying to understand. And so there's always going to be some uncertainty as to what the actual message is in any segment of any signal. And so that is what the information that the signal actually carries from the source. So our goal is to bring our observer's entropy down as close to that original entropy from the source as possible. And we do that by repeated observations or observing very long sequences. And so here we use the law of large numbers. So this table here is table 3 in the paper, and it spells out the terms of the model that I'm developing for how we can apply these mathematical concepts, relational concepts defined for communications theory and computer science to the archaeological record. And one thing that you'll notice that is different from mine and the original information theory is that I have two sources. So, and this is what I was talking about when I referenced issues with methods and what we're observing versus what we want. We only have access, direct access, to source 2, the archaeological record. We can sample that over and over and over and over again. But it also is a channel. It is a storage medium from the original. And so we have a gap between our two different sources. We can never sample source 1, the behavioral and systemic context, but we can reduce our uncertainty about that by repeatedly sampling the source 2, the archaeological record, and developing models of how behavior goes into material. Okay, and then I think I'm going on a long time now, so I'll just skip ahead. And everybody understands this formula, right? Probably not. That's the taking a version of, which I thought I had in here earlier. No, guess not. A version of Shannon's 1951 n-gram entropy and translating it with these terms for my model of archaeological information. And basically, the n-gram entropy is the remaining uncertainty given a set of prior observations. And so if you're reading a book or reading a paragraph and you get to that final sentence, if it's a well-written, well-structured paragraph, you will know a lot of what's going to be in that last sentence of the paragraph. And so we can take the probabilities of all of the combinations of all of the different symbols in that paragraph, plug it into you can't see me tracing with my finger, so plug it into a formula that looks like this, and it will give you the remaining amount of uncertainty that is left for the observation that you are about to make. And so we can apply that to archaeology. So we go out and we do our background research. We know about that it's a floodplain setting next to a terrace, and that there's some of Jared's earthworks up on the terrace up above us. Well, that reduces our uncertainty about what we're going to find a little bit. Then we go out and we do a shovel test survey on that floodplain, and we find some triangular points on the surface. We do a subsurface reconnaissance, and we go down and we find some pit features that have some chenopodium in them and some bladelets. And so that reduces our uncertainty still further. And so we can think of this as, so the received signal that we get is just a sample of each individual part. And so we keep combining these samples together, and those combinations reduce our uncertainty towards that original uncertainty of, in this case, source 2, the archaeological record. And I'll connect this also back to the issues, the liabilities of the standard methods. There's a lot of things that they miss. So we don't by standard necessarily do use-for analysis at the phase 1 level. We don't do soil chemistry analysis. We don't often even do geophysics at the phase 1 level. But because you find a lithic scatter that doesn't have any projectile points on it that are diagnostic, doesn't mean that if you had done the geochemistry and the geophysics that you would not have found features. And so that lithic scatter that doesn't have anything that tells you really what it is has a large amount of uncertainty and a very high conditional entropy, or this, my equivocation 3 down here, the conditional entropy of your composite sample. And so you would need to sample those kinds of sites to figure out what they are. If you can't predict the next observation, that is high entropy, then it has information potential. And so I guess I've kind of actually already summarized this slide, but so that's, I would argue that we need to shift towards using criteria D as this kind of information potential, that if it should be used, I would hope exclusively, but primarily for things that we don't know. And so the regulations even mention data gaps. And so it fits with the regulations, it fits with the words in the legislation and the regulations. and it's a formal way to measure the terms that are in there. And so we can use that and use criteria D to capture scientific significance. We can get representative samples that we can do science in the future about the past. And criteria A, B, and C can be used for the things that have that social value, the capital V humanistic value, things that we think are important for social reasons. We have to build an argument and justify why they fit their events or things that are related to broad patterns in our history, or why they're representative of a particularly important type of thing for criteria C. And so a lot of the things that are interesting that get recommended in the National Geographic principle under criteria T because they have information potential, really what we're saying is it'll be fun to dig there. Not everybody, I guess. But what you're conflating when you do that is data, the quantity of observations that you can make, and information. And so again, you're not going to pay. If you have to pay to see if a U follows a Q, nobody is going to pay for that, and they shouldn't. And there are a lot of examples analogous to that in the archaeological record, and we shouldn't pay for them because we say they have information. If that data is valuable in another sense, then yes, we should pay for that. But we shouldn't pay for it because it has information.